Hello everyone, we are going to discuss the new phase subject called classical electrodynamics. It is one of the most successful theory after the Newton particle mechanics. Newton particle mechanics, Huygens waves theory, uh, thermodynamics, and lastly the classical electrodynamics this are all of the classical physics. The All of the classical electrodynamics are described by the Maxwell equation with the Lorentz force law. There are 8 Maxwell equations, you can see that, and out of 4 of them um, differential, and another rest of them are integral. And there is a force law called Lorentz force law. Sorry, Lorentz force law. That is this equation. Okay. According to what is the scope of the electrodynamics? Why we need the quantum electrodynamics? Actually, according to the modern physics, there are 4 fundamental forces, namely the electromagnetic, gravitational, weak nuclear, strong nuclear forces. The strong nuclear forces, the most powerful force in this universe is the strong nuclear force or strong interaction. And second powerful force is the electromagnetic force. Historically, the electric and magnetic forces magnetic forces discovered separately, and physicists unified these forces into single force, namely the electromagnetic force. People realized that these two forces depended about the coordinates. So I later discussed these forces, how these two forces unified. I later discuss this later upcoming lecture. Okay. The classical electrodynamics describes this force in the fields of the classical field, namely the classical electrodynamics. Classical electrodynamics field, in later lecture I discussed that the electromagnetic field is described by the electromagnetic field tensor. Okay. Branches of electrodynamics. There are 3 branches of the electromagnetism. First branch is the electrostatics, second branch is the magnetostatics, and third branch is the electrodynamics. The electrostatics is the branch in which all the charges are in rest, and force exerted between them are governed by the electrostatic force, and formula given by the Coulomb's law. Magnetostatics. The study of phenomena when all charges are moving in uniform velocity. The uniformly moving charges or currents produce the magnetic field, and this magnetic field described by the Biot-Savart law. The electrodynamics. Electrodynamics is the study of the electromagnetic induction. What is electromagnetic induction? The changing magnetic flux creates the EMF, electromotive force. This is called the electromagnetic induction, and this is governed by the Faraday's law and Lenz's law. Okay. Astonishing prediction of the classical electrodynamics. Maxwell showed that it is possible to have the electromagnetic waves that propagate through the empty vacuum space with the light of speed. Hence, he proved that the light is a speed type of electromagnetic wave and calculated its speed. Albert Einstein discovered his relativity, observing that the speed of light is constant and proved that there is no jelly-like ether. He observed that under the Galilean transformation, the new wave equation of the electromagnetic waves became non-invariant, and but under the Lorentz transformation, this equation became invariant. Hence, he developed new kind of kinematics and dynamics by the uh, from the classical electrodynamics. An covariant form of the Maxwell equation is required to develop the and quantum electrodynamics. Quantum electrodynamics is the subject, very extremely rich subject, and very it is indeed very needed the Maxwell equation. I hereby conclude that the Maxwell classical electrodynamics is the very best and classical field theory, and it is successfully describe all the macroscopic phenomena involving the electromagnetic waves. Thank you everybody for listening.